Hello my dear children, good morning. I am going to continue this chapter, long form of periodic table, classification of elements and periodic properties. In this chapter I have already discussed about the various topics. Now I am going to continue about the periodic properties. There are various periodic properties which are in our course. Out of these, in my previous lecture, I was discussed about the atomic radii, atomic size. Now I am going to continue my second topic, and that one is ionic radii. What is ionic radii? You know that what are ions? Ions are charged atom or group of atoms like Na plus, Cl minus, Mg2 plus, O double minus. These are the various types of ions. Ions are charged atoms or group of atoms. In this topic, I am going to discuss about the types of ions and what is the size of the ion. You know that ions are of two types, positive charge and negative charge. Positive charged ions are called cations and negative charged ions are called anions. The distance between center of nucleus to the outermost shell of positive ion or in negative ion, this distance is known as ionic radius. The distance from center of nucleus to the outermost shell in an ion is called ionic radius. The size of cations, means positive ions, is always smaller than its parent atom. Means in Na and Na plus, which of the particle has greater size, Na or Na plus? Na is greater than Na plus. Means the size of cation, positive ion, is always smaller than neutral atom. Here also Mg, Mg2 plus. Mg is greater than Mg2 plus. The size of cation is always smaller than neutral atom. And in opposite to this, the size of anion is always greater than neutral atom. Means Cl minus is greater than Cl atom. O is less than O double minus. O2 minus is greater than O, oxygen atom. In this way, the size of cation is always smaller than neutral atom and size of anion is always greater than neutral atom. Okay. Why so? This is due to when an atom loses electron, the effective nuclear charge. What is this? This one is effective nuclear charge. When an atom loses electron, the effective nuclear charge increases and hence the atomic size decreases. In opposite to this, when an atom gains electron, the effective nuclear charge decreases and hence atomic size increases. Z effective increases in this case and in this case Z effective decreases. So that the size of anion is always greater than neutral atom here also. If there are some isoelectronic species, means when both of the two or more ions have same number of electrons, in isoelectronic species like O double minus, F minus, Na plus, Mg2 plus, Al3 plus, among these, they all are isoelectronic. Among these, which of the ion has greater size which of the ion has smaller size? Atomic number of Al is 13, here 9, 8, 11, 12. They all have 10 electrons, means you can say they all are isoelectronic. Here, as the number of negative ions increases, the atomic size increases. Means among these, which of the ion has the smallest size? Then it will be Al3 plus. Al3 plus is the smallest among these. Then Mg2 plus is greater than this. Then Na plus means lesser the number of positive ions, greater is the size. Now in negative ions, greater the number of negative ions, greater is the size. F minus is smaller and O2 minus is largest among them. Okay. In this way, I was discussing about the ionic size. Now I am going to explain third topic, ionization potential or ionization enthalpy, IE. What is ionization enthalpy? You know that nucleus is surrounded by a large number of shells and these shells contain electrons. These electrons can be removed or entered. To remove an electron from isolated gaseous atom, the energy required is called ionization potential or ionization enthalpy. Okay? What is ionization potential? The amount of energy required to remove an electron from isolated gaseous atom is called ionization potential or ionization enthalpy. It is expressed in kilojoule per mole or in electron volt per mole. The energy required to remove first electron is called first ionization energy. Means the energy required to release first electron, this energy is called ionization enthalpy. What? First ionization enthalpy. Now I want to remove second electron, then more energy is required than first one. Means this energy is called IE2. Means you can say that IE2 is greater than IE1. Why so? This is a very important question. Why second ionization enthalpy is greater than first ionization enthalpy? This is because when an electron is lost by an atom, the effective nuclear charge increases. The effective nuclear charge increases, which requires more energy to remove second electron. And so on. If you want to remove third electron, then more energy. Means IE3 is much greater than IE2 is much greater than IE1. In this way, energy is required to remove electron. Within any period, on moving from left to right, the ionization enthalpy increases. This is because atomic radius, or you can say atomic size, decreases. On going from left to right within any period, ionization enthalpy increases, means Li, Be, Bc, No, F, Ne, and so on. In any period on going from left to right, ionization enthalpy increases with few exceptions. Here, a few exceptions are also present, which I will discuss later. Within any group, on going from top to bottom, on going from top to bottom, ionization enthalpy decreases. This is because atomic size increases. This is the trend of variation of ionization enthalpy within a period and within a group. Okay? Thank you.